Welcome to Algebra for Success, where we're delving into the fundamental building blocks of algebra. In this segment, we'll explore basic algebraic operations. These are the essential operations that form the backbone of algebra. So, let's dive right in. Basic algebraic operations include addition, subtraction, multiplication, and division. These operations are the bread and butter of algebra, and they are used to perform calculations with numbers and variables. Before we delve into the specifics of addition, subtraction, multiplication, and division, it's important to understand why these operations are so crucial in mathematics, and in particular, in algebra. Algebraic operations provide us with the tools to work with and manipulate numbers, quantities, and variables. They help us solve equations, simplify complex expressions, analyze patterns, and make sense of real-world problems. These operations are like the building blocks of mathematics, allowing us to perform calculations and uncover relationships between numbers and variables. In essence, algebraic operations are the foundation of mathematical problem solving. They empower us to find solutions, make predictions, and gain deeper insights into the world around us. As we explore each operation, you'll see how they enable us to tackle a wide range of mathematical challenges and uncover hidden truths. Let's go over them to make it crystal clear. Let's start by delving into addition. This operation is all about the art of combining numbers. When we add numbers together, we're essentially seeking their sum, the result of this addition. It's a fundamental concept in mathematics. For example, consider the simple addition of 5 and 3. When we add these two numbers, we get the sum, which is 8. In algebra, the world of variables opens up. Instead of working solely with concrete numbers, we often encounter expressions like x plus 2, where x isn't a fixed number but can take on various values. So, in algebra, addition is a versatile tool. It allows us to work with variables that can represent a wide range of numerical values. This flexibility is at the core of algebra's power, as it empowers us to tackle problems that involve unknowns and discover relationships between different quantities. As we continue, we'll see how addition, along with its counterparts, subtraction, multiplication, and division, play pivotal roles in this mathematical adventure. Subtraction, in essence, is the counterpart of addition. It's the operation of taking one number away from another, and it's vital in both everyday mathematics and algebra. To illustrate, if we subtract 3 from 8, the result is 5. This is fairly straightforward. In algebra, subtraction works in a similar manner. For instance, if we encounter an expression like y minus 4, it means we're subtracting 4 from the variable y. This algebraic concept allows us to represent and manipulate relationships where quantities need to be diminished or taken away, such as when you want to find the difference between two values. It is a fundamental operation that comes into play in various algebraic scenarios. Multiplication is a fundamental operation that can be thought of as repeated addition. When you multiply two numbers, you're essentially adding one number repeatedly as many times as indicated by the other number. For example, if you multiply 3 by 4, you're effectively adding 3 4 times, which results in a total of 12. This concept is at the heart of multiplication. In algebra, multiplication plays a crucial role as well. You might come across expressions like 2x, where x represents a variable that stands in for an unknown number. In this case, 2x means 2 times x. It signifies that you should take the value of x and multiply it by 2. Algebra often deals with variables, and multiplication is a powerful tool to express relationships and calculate results when these variables are involved. Division is the counterpart of multiplication, and it involves splitting one quantity into equal parts. To grasp the concept of division, consider a simple example. If you divide 12 by 4, you're essentially breaking down 12 into 4 equal parts. Each part is 3, and that's the result you obtain. This is the essence of division, determining how many times one number can be evenly distributed into another. In algebra, you'll encounter expressions like 6 divided by a. Here, a represents a variable that stands for a number. The expression signifies that we're dividing 6 by the value of a. Just as an arithmetic, division in algebra aims to uncover how many times one quantity can be divided into another, even when dealing with variables. Division, therefore, is a crucial operation that enables us to work with unknown values and express relationships between them. If you want to succeed in algebra, you must remember my CFAR Rule. This rule includes 4 tips you should implement in order to achieve success in algebra. It means stay organized, follow the order, and practice regularly. Let's see what each mean. Stay organized. Make sure to clearly separate numbers from variables so you don't get confused when performing operations. Follow the order. The order in which you perform operations matters. We'll cover that in the next segment on the order of operations. Practice regularly. The more you practice these basic operations, the more confident you'll become. It's all about building a strong foundation. Remember, these basic operations are the building blocks of more complex algebraic concepts. As you progress through the course, you'll see how these operations form the foundation for solving equations, working with polynomials, and exploring advanced algebra topics. So there you have it. Basic algebraic operations are your stepping stones to algebraic success. In the next part of our course, we'll explore the order of operations, a critical concept to ensure your calculations are accurate and consistent. Keep practicing, keep learning, and you'll be well on your way to acing your algebra class. See you in the next segment.